Okay, cool. So good morning, everyone. Welcome. It is the first tutorial for CO1. Today we'll be going over REST APIs and Git. REST APIs, I believe, will be covered in lecture this week. Uh, and Git is extra. So it's definitely really important to know because this is, how you'll be managing your software in such a large team of up to 7, right? So for this tutorial, first we're going to go over Git. What is Git? I know you guys use SVN for 207, or sorry, B07. So pretty similar, just a few differences. And then we're going to talk about merging versus rebasing, and then Git flow. So Git flow is essentially how your team should be structuring your Git repository for your project to make sure it's, well managed and orderly. And then we're going to talk about HTTP requests and then REST APIs. We were allowed Git in B07. Oh, okay. That's different than like the last term that I had. They had to use SVN in 207 or something. Cool. So let's go over some info. So so for all tutorials, participation is required. So tutorials will alternate between the workshop format and then also the project demos. For your groups, team.md is due this Friday, so make sure you create a GitHub team through the link. Please don't use placeholder link like CO1 group, CO1 project. Uh, in previous terms, we've had like 3 groups do that, so it gets confusing. So, it would be great if you could set it to like a name after your product or project, but if you don't have, if you haven't thought of that by Friday, you can just come up with a name for your team. Like, I don't know, Brute Force Solutions. That was a cool name from last term. We use Git in the summer. Okay, cool. That's good to hear. And after the team MD is done and all the GitHub teams are created, we're going to put out a sign up for the project tutorials. So for these demo tutorials, you'll have to attend the same tutorial as your team. And yeah, we'll put out a Google form on the website. One thing to note is like the in-person tutorials will be online for those demos, just because some groups might have some students that can attend the in-person and then some that can't. So we're just making it online so that everyone can go, right? Cool. Any administrivia questions before I get cracking? Okay, I'm gonna take that as a no. What form are the participation in? Google. I think it says right here. Yeah, we're using Google Forms. Oh, sorry. What for? I think I misinterpreted that. We're gonna be using it's like a quiz software. I think Professor Alir developed it with like students, but basically I'll send a link and then you guys fill it out. It's not marked for correctness. And then we're gonna talk about why we got to a certain answer and stuff so that we can have that discussion. Cool. Moving on. Who am I? I'm in my last term actually, CS spec. I like full stack development, interned at City and Water Hub, sold my soul to banks, so I'm going full time to JP Morgan Chase after in January. I like playing strategy games, and I have a dog named Molly, and I listen to a lot of music. That is me, TFT. Yeah, currently Diamond, but I need to catch up on the meta. Donda. Yeah, Donda was pretty solid, man. All right. So let's talk about Git. So Git is a distributed version control system that enables teams of software engineers to collaboratively work on repositories of code. So what this means is that everyone has a copy of the Git repo, right? But there's a difference between local and remote. So you can have your own version of the local remote repo that differs from the remote, and then you push and pull changes back and forth so that it's managed. It was an open source project started by Linus Torvalds and the most popular version control system used by software engineers currently. Modifications to the code base are represented as commit objects, and the Git history is just an immutable linked list of commits. And yeah, as you guys mentioned, you've been exposed to it in previous courses such as BO7 and the basic commands: add, commit, push, pull, clone. But before you work on like a huge project with team members, you don't really know the inner workings of Git, right? You don't know when to do stuff, right? I feel like everyone just knows the three basic stuff: add, commit, push, and then they call it a day. And then before I took 301, that was all I did with Git too. I just like solving merge conflicts. Oh, geez. And that makes one of us. So what is the typical Git usage? So we're going to talk more about Git flow, but essentially what you want to do is branch off of main or develop and then create your feature branch, implement your feature. Are we allowed to use GitHub desktop? Yes, that's fine. And then you're going to add the untracked files to your commit. Also before you like commit, I like to do git status just to ensure what files have I added to the commit, and then make sure I'm not pushing anything like .envs or any .id idea, I think is the one that JetBrains uses. Just so nothing is cluttering the repository, right? And then you're going to create your commit, providing a present tense, concise message for the changes that you've made. And then you're going to push the commit into your branch. And then once the feature's done, you're going to merge the feature branch into main or develop, hopefully via PR or pull request, but we'll talk about that a bit later. Time for git ignore. Yeah, git ignores are great. Cool. So sounds pretty easy, but things can get complicated, right? It's an immutable system, so it's really hard to reverse changes, but it's definitely not impossible. So a lot of issues that people run into Git are what if someone pushes code to the main branch that I need for my feature branch? What if I have to undo a commit? And what if I want to reset local changes? So we're gonna talk about all of that stuff, because no doubt that will probably happen to you during your project. So first one, what if someone pushes code to the main branch that I need for my feature branch? There are two methods for bringing code in from other branches into your own, and they are merging and rebasing. So merging essentially combines branches together into a commit, and then rebasing essentially modifies the history and mutates it, and it moves commits on your branch so that all of your changes come after the ones that have been implemented. So it's a bit hard to talk about in words, but I have some graphical representations that should help. Okay, so firstly, merging. So command is git merge, and then you specify the branch. Merging creates a commit which combines the tip of the master branch, the head, and the tip of the feature branch into one commit. So it's usually called a merge commit, and then the merge commit becomes the new head after the merge is complete. So let's look at that. Not graphically. I have pros and cons first. So pros, it's non-destructive, doesn't alter any existing branches. And if you're new to Git, generally I recommend that you use merge, just because it's simpler to manage. It's not as complicated, just because rebasing is great, but if you don't know what you're doing, sometimes it can backfire. And one con is that it pollutes the master branch with extra merge commits. This can become an issue in high traffic projects with many contributors, right? So there's an example right there. You can see bang, 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 like all of these merge conf commits, right? Can you merge branches with branches other than master? Yes. Yeah. Cool. Okay, now we got our graphical representation. Let me just check the chat. Squash commits. Yep, I like squashing commits. Well, we'll talk about that later. So cool. So let's say we have master branch and then some new feature branch. And then on master, we have commits 1 and 2. We're going to branch off of master and then do some work, commit 3 right here. And then maybe on master, someone merges in a feature. Cool. And then some other commit 5, maybe we like wrote the tests for a feature and then in 3, it was only the implementation. So when we merge it in, it's going to, take these commits, create a new commit, and then all of the changes implemented here will be reflected into the master commit, the master merge commit. Okay, before I continue on to rebasing, any questions about merging?
So I just have a quick question about
Yep.
the git merge. So in a master branch, like in the commit 4, if somebody is doing some work which is different than the work you are doing in the new branch, and like when you are pushing in the master branch and then you are merging the commit 5, would that bring the merge conflict because you have the changes?
Great question. So yeah, sometimes merge conflicts can happen. Like it is pretty annoying, right? When you branch off from here and then everything is good, but then someone brings in changes that conflict with your code. So in that case, if you are holistically only using git merge, what you would do is actually re-merge master into your new branch so that their changes are back in, and then you would resolve the merge conflict and then push those resolved changes into your branch and then merge back into master. So it's all good. Does that make sense?
Okay, thank you.
Cool. Alternatively, you could rebase it, but we'll talk about that in the next slide. Cool. So rebasing moves things around. The first commit of the feature branch is placed sequentially after the tip you're rebasing onto. The command is git rebase and then the branch name, pretty similar to git merge. And the benefit of this is that there's no extra commit merging the two. It partially rewrites the git history by creating brand new commits for each commit in the master branch. And it requires an extra step to merge. So in this case, you have to rebase the feature branch on master and then you merge it in. So this is good for the scenario that I believe Ritik mentioned earlier, which is what do you do when someone touches code that conflicts with your own feature branch? So by pulling in master before yours, there's a lot less merge conflicts that you run into, at least in my experience. Cool. So pros and cons: cleaner project history, no unnecessary merge commits, linear history is maintained. So it's really easy to follow the entire history of the project from the tip of the feature branch back all the way to where master was beforehand. But it does require caution, right? I mean, everything in life has a cost, right? If it's cool, it's definitely got to be difficult. So never rebase a public branch onto your feature branch. This will result in 2 different versions of the master branch, which will need to be merged back together. I believe this is more so an issue of like if you have forks. We don't cover that in this course, but I figured it was good for mentioning, especially if you do like open source contributions. Yeah. Can you give an example of rebase? I will right here. So let's say we have commit 1 and 2 in master, and then I'm working on a feature branch, same thing, commit 3. Someone puts a commit on the master branch, maybe some feature, right? And then I finish up my feature. So how do I cleanly merge this branch in? So rather than git merging, we can rebase, in which case our linear history will be modified, and then commit 4 will actually be the head of our feature branch, and then, the changes can be merged in more cleanly. If you had conflicts before rebasing, wouldn't that mean you had to resolve all the previous conflicts again? Let me just see if I can understand this. Yeah. So does commit 4 stuff get replaced by commit 3? The changes are layered on top. Like for example, in commit 1, 2, you have conflict. Ideally, your master branch should not have conflicts, right? So we'll talk about that later in Git flow. But okay, let's say that there was a conflict. Yeah, you would have to still restore it. But ideally, the master branch should have no. It should be like a perfectly working version of software. We'll talk about that later in Git flow. Okay, cool. So what if I have to undo a commit? So it's designed to be immutable, so undoing things can be dicey, as I mentioned. But Git offers a lot of tools: reverting, restoring, resetting, and stashing. So I have a slide for each. Let's see. Undoing things in Git, reverting. So things break, commits introduce bugs, etc. This is perfectly normal. The most simple form of undoing in Git is a revert. So essentially, it just creates a new commit that simply undoes the commit which was specified. Reverting is not ideal if you want to undo something locally without an extra commit. So essentially, I've committed something to the branch, it breaks something, and I want to undo that commit. Since Git is like, since Git tracks the additions and deletions of files, when I revert it, it'll just get completely undone, right? Cool. Resetting resets the state of the repository back to a certain state in the past in various ways. So if you provide the soft flag, this will modify where the head points, staged and unstaged changes are not touched, and previous commits become staged files. You could specify mixed, modifies where the head points, wipes the index clean, aka the stage files, but doesn't touch unstaged files. Previous commits become unstaged files. Sorry, does the git revert just go back a commit? Yes, essentially. So it creates a new commit with the inverse of that commit. So the state goes back to before the commit was made. Yeah. And then git reset hard, nukes everything, be careful when using. Stage and unstaged files reset to the specific commit. The head is updated and previous commits are gone. So yeah, be careful about using hard, but there are times when you need to do it sometimes. All right, restoring and stashing. Reset hard is the same as revert, kinda. Cool. So restoring / stashing. So what if you want to reset locals changes? So the prior two commands were just for, when you've committed something onto your branch. But what if, I was trying something out and then it didn't work, so I just want to go to the previous state. So you can do git restore to reset the state of the repository to the latest commit. It can be used to restore one or more files based on the provided file path. So yeah, you just do git restore, specify the files, and then it'll reset it to the state of the previous commit. And then git stash. This is one that I like to do, like when resolving like merge conflicts. So you store the locally modified files into a stash commit, and then it can be popped from to restore changes. So essentially you just git stash, it'll take all of the local changes, create a stash commit locally, right? And then you would just git stash pop when you want to use it, and you can also clear the stash. Cool. All right, git flow. How am I on time? 9:30. Doing good. All right. So git flow is a commonly used Git branch structure that promotes agile software development and continuous integration / continuous deployment, which we'll be talking about in future tutorials. But the master branch stores the official release history, and the develop branch is used to integrate features, right? So, in the industry, they use Git flow a lot. What this means with continuous integration / continuous deployment is that, you can have it set so that the code base on master will deploy to the user, the production environment, and then develop. You could have like a staging environment for devs so they can QA and stuff. And then, you branch off of develop for all your feature branches, and then it's merged in. And, this is all the work for the upcoming release. Okay. So feature branches are merged into develop once develop has been thoroughly tested and contains all the features / fixes for a release. You merge develop into master. If there are issues with a feature, we can revert the feature branch in develop. And then if there are issues with the release, we can revert the merge commit in master, right? So sometimes this happens. It's totally okay. Even with all the fancy continuous integration tools, sometimes things slip through. So with Git flow, it essentially allows you to manage your environments really well. Yeah, result, isolating our environments prevents issues from becoming a problem. And then since there's, production versus staging, the feature branches, can be integrated and develop, and then when it's merged into master, it's like facing the users, right? Cool. Okay, cool. So we have a participation question here. So in the event of a production issue, how should you fix it? So I have this link here, and I think you guys can see my screen. So you're going to be prompted to log in with your uTor ID. Just log in, and then I'm going to start the quiz. You guys should be able to answer it, hopefully. Is it working? What do you mean by production issue? Okay, so essentially what that means is, can you guys see my screen right now? If you click on the link, you should be able to see this. So the options are create a feature branch off master, merge into master when done, etc. What was the question? Sorry. In the event of a production issue, how should you fix it? You can only see the options. Okay, how about I do this? Split screen action. There you go. What do you mean by production issue? So essentially, let's say a release has been done, and then users are reporting like a critical bug, like, oh, when I go on this page, it allows me to access user info or user restricted pages, as an example. Cool. So I'm gonna give it like 2 minutes. We have about 39 people, so hopefully everyone can answer. I feel like the options aren't really matching the question. Maybe Alir set it up wrong. I don't know. We'll figure it out. But it doesn't really matter too much because it's marked for participation only. Cool. Perfect 39. Wow. All right, let's see. So we had 12 people that said create a feature branch off master, merge into master when done. Create a feature branch from develop, merge and develop, then push the fix in the next release. Push changes directly on master, none of the above. Okay, let's see. Would anyone like to that answered this one? Could you give a brief explanation of why you chose that? Feel free to unmute or type. But if no one answers, in a minute I'll talk about. I'll move on. Okay, no one seems to want to. So, anyone? Okay, I mean, I get just for all of for all of the answers, just prepend it with like A, B, C, D, and then maybe provide an explanation. We don't have to go one by one. B, you want to make sure you change, don't introduce more bugs. Okay, good point. Seems to be a safer way. Okay. It's a production issue, so the bug must be present in master, so you need to branch off master. Okay, good points.
Yeah, so for the first one, maybe what I think is like when you are doing the production, it is kind of like from your side already tested and everything. So it is coming on the production side. So when there's an issue, maybe there you can kind of create a branch. For example, maybe call it like a testing or like a bug branch where you are kind of fixing all the bugs. And then once it is fixed, you can just merge into the master. But as far as the second one is, it is maybe more like someone mentioned, more kind of a safer way into that you kind of test again, do much more work, and then kind of just merge the master. So I think like A and B are kind of similar in a way.
Right. Okay. So great answers, everyone. Thank you, Ritik, for your input as well. Um, so it actually is kind of variable, right? It kind of depends on the situation. Um, that's kind of on the question because it's not super clear. But if it's like a massive issue, typically we would branch off of master, create a hotfix branch, and then merge it in. The only thing that kind of sucks is that because you did a commit on master and not develop, you have to do a back merge, right? Merge master into develop so that the hotfix is propagated. But yeah, as you said, it is a judgment call. So if it's a massive issue, then you would want to branch off of master. But if it's not too bad, and it really depends on the scenario. So it is a judgment call. But as you guys said, develop would be the safer option. It would be nicer to follow Git flow, right? Doesn't A break Git flow rules though? It does and it doesn't. So like, yes, all the commits on master should only be releases, but the thing is, issues happen. And in that case, it's acceptable, right? Okay, cool. Thank you, everyone. I thought if there's an issue with the main branch, you revert. Yeah, that is one thing you could do. So you could revert the release, commit, and then fix it and develop. It really depends on the scenario. Like, yeah, it's just too hard to determine from the question. So I guess that's on us because it wasn't really specific. But the purpose of it being open-ended was that there are a lot of great answers. So thank you everyone for that. Cool. So pull requests. So this is the crux of the Git workflow. So after pushing your changes into a branch, you create a pull request. It's also called merge request on like GitLab. What's the one for Atlassian? I forget the name. I swear I do. Oh, Bitbucket. It's also called merge request on Bitbucket. From your branch into the develop branch. If you have continuous integration, then automated checks will run against it, informing you of any bugs and errors. So essentially, your CI will run a whole bunch of test suites on your code to ensure nothing breaks. And then it can then be reviewed by one or more engineers where they can provide comments on how to improve it, just allows more transparency, feedback and stuff, cooperation. So That is why it's great. So here's an example. This is from the AWS Amplify repo. So this is an example of a PR description. So has a description of changes, an issue number. The reason why that it has an issue number is that you can set it up so that when you merge the pull request, it'll close the GitHub issue. But since we're doing Jira, that doesn't really apply. Description of how you validate changes, right? It's always good to provide your QA process. And then there's some little checklists right there. So description included, yarn test passes, test or changes are added, and then relevant documentation is changed or added. Can you repeat what you just said? Okay, sorry. Let's see, where do I start? So yeah, so this is a pull request from the AWS Amplify repo. It contains a description of changes, an issue number. The reason for the issue number is that on GitHub, if you set it up properly, when you merge in a pull request, it'll automatically close an issue. That doesn't really apply to us because you're using Jira though, but it is just something to be aware of. And then they didn't provide a description of how you validated changes, but you should, right? It's important to tell your team how you QA'd it. And then there's just a basic checklist. So PR description included, yarn test passes, etc. And then if you click on files changed, you can look at all the changes, and then you can actually like highlight text, make comments and stuff. So this is probably the best part of pull requests in that you can leave comments for individual parts of code, and then provide feedback for the contributor. Okay, I actually have a pull request template that I can send you guys after. Maybe I'll put it on the site, but let's see. Merging in pull requests. So after being approved, use the GitHub UI to merge your pull request. We recommend squashing and merging your commits so that all your changes are added to develop as one commit. It's a nice way to encapsulate the changes and ensure the commit history of develop is clean. So someone mentioned this earlier, but they like squashing, and I agree, squashing is great. So let me go back to this example here, right here. So let's say that we have two commits. If you merge without squashing, then these commits would be like added in. So it'll be the history of master would be 1, 2, 4, 3, 5, and then the merge commit. But if you squash it, then these two commits will just become one. So it's pretty clean. After squashing, can you check the individual commits on the feature branch, or is that lost? The feature branch is separated, so yeah, you will be able to see the individual commits on the feature branch. But in the branch you merge to, these two commits would just become one. Okay, we're a bit tight on time, so I'm gonna try to speed through this. Let's say if you have merged through, you've completed the work for your feature in a feature branch. Let's call it dev 101. How should it be merged in? Start. So everyone please vote. Review the questions. Cool. 6 people. 4 people left. One person left. All right, sweet. So the options were create a pull request, reach out to team members to review it, implement any required changes, then merge when approved. Yeah, this isn't really a trick question. It should be this one, right? If we're operating under Git flow, it should be this one, you know. Check out master. And this would also follow Git flow. I mean, maybe if you're a solo contributor. Um, oh wow, the things changed. That's interesting. Did you guys switch your votes? Okay, cool. Let's see. So I'm gonna try to speed through this. Cool. So HTTP request, so it's the basis of communication on the internet. When you type in the URL, uniform resource locator of a website, your web browser sends a GET request to the server to provide the required files for displaying the site. Try opening the browser console, clicking the network tab and loading in a page. You'll be able to see all the network requests made. Yeah, let's try that. So I'm gonna open up my dev tools here and I'm on the network tab and let's go on the fall 21 site. After loading it, you can see all of this stuff. You can even see our embarrassing names for the files. But yeah, you can see all of the HTTP requests that are made from the site. And this is a good way to debug stuff when you have HTTP requests later on. Cool. So there's 5 types of requests we can issue, which cover the basis of CRUDing or creating, reading, updating, and deleting data. So get method used to request data from a source, and you can provide extra arguments in the query params. Post, create, or update a resource with provided data, and information is provided in the request body. Patch, update a resource providing the changes. Request body, and then put update a resource providing the entire modified resource, which is stored in the request body, and then delete a resource, and then query params. So I don't know if you guys have heard of Postman, but this is a pretty useful client for sending requests, and we're gonna look at that later. I don't understand put. Yeah, so that's a great question. I've been asked on job interviews, like, what's the difference between patch and put? So essentially, they both update a resource, right? But for patch, you only provide the things that you're changing for that. So let's say, I don't know, I have a user and then I have a form for updating their email. After validating all the information is good, I could send a patch request providing just the changed email, and then my API should take that from the request body and then modify it. But with put, you would provide the entire modified resource. So I would send in the request body, I would send in, user ID, the user's name, the new user email, their password, etc. So it's essentially just like, this is what this is patch is, this is what I want to change the resource to, and then put is, this is the entire resource, like set it, Yeah, kind of like a setter if you think about it. That's a good way to think about it. Can you give an example of each? They kind of seem similar. Yeah, they are. Like, as I said, for patch, let's say you're updating a user's email, you would just provide the changed email in the request body. But for put, you have to provide the entire modified resource. So, there's information in there that's not being modified, like user ID, email, name, etc. Oh, which scenario would you use each? Okay, if I have time, I'll circle back to that. Sorry. Cool. So take, for example, this endpoint from the GitHub API, get repos owner repo. So essentially, we would issue a request to this URL, api.github.com. and then you specify the owner here and the repo here in the URL. What do you guys think the response would contain? So we're sending a request to the GitHub API for repos, and we're providing the owner and the repo. Code, README. Okay, those are some good answers. All right, why don't we just try it? Oops, I closed the chat. Let's just try. Oh God. I've got Postman open right here, so I'm gonna don't look at that. So I've got the get request right here. And I've provided the URL. So let's send. And okay, let me hit the pretty version. Yeah, so as you said, it is a big JSON object. And it contains a ton of information about this repo. So it says, hey, this repo has these amount of people that started it, this amount of people are watching it, information like has issues, has projects, etc. Why do you guys think there's a ton of URLs here? Like, what is the purpose of this? Okay, no takers, no worries. For scraping more data. Yeah, you're right about that. So since everything is done through, you sending requests to URLs, if I want to get more data, you need the URL to access that data. So you're exactly right. Cool. And then what do we expect the response to be? Information about the Hello World repository under the Octocat owner. Do we need to have Postman? No, but it's definitely good to. It's a nice way of manually testing your APIs for like A1 and A2. Okay, so after issuing an HTTP request, we expect to receive a status code and response body, typically JSON. HTTP statuses describe what the server did in response to the request. So 200, okay, the response is exceeded. Definitely want to see this when we send a request. 201 created, the request has succeeded and the resource has been created. And this is usually done for post. 400 bad requests, the server cannot understand the request due to invalid syntax from the person requesting, right? Like maybe I put in a string where user ID should be, and we expect a number. 401 unauthorized, the client is not allowed to get the requested response. So in Postman, there's actually like auth headers and stuff. So that's where you would put that information so that the API will validate you and give you the stuff that you're asking for. 404 not found, server cannot find the requested resource. And 500 internal server error. The server has encountered an issue while processing your request. Cool. Let's see. I have 6 minutes. I'm just gonna skip this if that's okay, just because it's covered in lecture. Feel free to review that on your own time. Let's see. APIs consist of endpoints, which are defined methods to handle HTTP requests. After the API receives a request, it performs request handling and then routes it to the proper endpoint. Endpoints are defined by HTTP verb and a URL. So we have post books here, get users /UID. What does everyone think the endpoint URL would be for deleting a book? Have you posted the slides? Yeah, it's on the website under tutorials tab. What would the endpoint be for deleting a book? /delete book ID. Okay, let's delete books book ID. delete books. Yeah, so it's Joshua's. So it'll be delete slash books, and then you would provide the book ID so that it can be, we're providing everything it needs to know, right? The book ID, and then what's happening to the book. Yep. Cool. I put the ID, but it doesn't really matter. All right, let's see. 4 minutes for a simple API. Okay. Let's see what else we got. Blah blah blah. Okay. Yeah, we should be good. At minimum, I'm just gonna do this demo, and then I guess we're not gonna do question 3. So I'll make sure that that is not considered for the participation. But yeah, so let's take a look at an API for adding and subtracting numbers. I'm not sure if Alir has shown you an API in lecture, but this is one that we created. Okay, he hasn't. Awesome. Cool. So this is a API, very simple API that we've created. Let's start with the app.java, right? So in this folder, this is where all our code is running from, right? So we create a server, and then we're creating context, which is essentially it's saying when a request arrives at this URL, this class is going to handle it. So we have one for adding 2 numbers and then subtracting 2 numbers. Cool. So before we look at add or subtract, let's look at endpoint. So this is an abstract class that essentially handles the behavior for the HTTP request. So when you send a response to this API, to this path, it'll get handled by this method and then route it directly. So if the request method equals post, then we're gonna use our handle post method. And then this is just an abstract method to ensure that the inheriting classes implement it so that it can be routed properly, right? Cool. So that is add. And then when we jump into add right here, we're inheriting from endpoint and implementing handle post. There's a lot of info here, so just review it on your own time. But the gist of it is we're getting first number and second number from the request body, and then we are adding it together and then sending the response. So what happens? Actually, am I running it? No. Oh, that's the test I'm running there. There you go. Let me run the server. Cool. So let's just add 1 and 2, and then we get 3. Cool, it works. Awesome. Let's see, 2 minutes. One thing I wanted to talk about was testing, because this is going to be important for A1 and A2. So this is a test that I made. And can we use Node.js for your project? Sure, but not for the assignments. And I'm just going to run this test using this. Run the test. Cool, it passed. What does the test do though? So right here, we're specifying the API URL as a constant. And then we have this method to send a request. It uses the Java HTTP client, and then we build the request. So, we specify the URL and then the endpoint that's provided right here. And then we send the request. So this is just a generalized method that I made. It's not perfect, but it is pretty extensible because it lets me send, get requests, post requests for all of my tests. Okay, so that's that. And lastly, this is add 2 numbers with the post method. So we create a body, a JSON object representing the request body, place 1 and 1 in first and second number. We send the request, and then we're going to assert the response in the body. So we're out of time, but feel free to download this on the site. You can create a test for sub 2 numbers, and then also complete the handle post method. This isn't, being collected. It's just if you do this for the assignment, it'll help out a lot. So if you have spare time, go ahead and have at it. Yeah. That's it for me. Sorry for, kind of being rushed. Um, but yeah, any questions? Oh, actually, you know what? I have a class right now. So, sorry, any questions? If you still have any questions, please put them on Piazza. Thank you for coming, everyone. Yeah, and see you next week. CO9 feels like a prereq. That is a good point. Yeah, a lot of stuff is um, kind of shared between CO1 and CO9. But in my experience, I don't know how CO9 is done. I took 309 at UTM. Uh, I learned the most about web programming in 301 rather than 309. Let's see. Thanks for the tutorial. Thank you, everyone. Sia, Ange, Yuval, Yusuf, Jijuan, Ansel, Sarah, Serena, Hongzhao. Do we have attendance? No, it's captured through the quizzes. Thanks. Sia Nimra, Waiter, Tony, Rohan, Shu, Samiha, Su, Jali, Pasa, Xiaopeng. Cool. See you guys next week. I'm gonna head out to my next class. Please add CO1 to the quiz link. Oh, does this a 207? Let's see. 236. Yeah. Okay. I'll get a layer to do that. All right. And now I have to stop the recording.